Okay guys, so essentially we are looking at translating graphs, okay? So a translation, this is part of the new topic that we're doing, which is linear transformations, okay? A transformation is essentially something that changes a graph in some way. A translation is a specific type of transformation. A translation is when we move a graph in a certain direction without changing anything about its shape. Okay, no reflection, no rotation, enlargement, squashing, stretching, none of that, just moving. So moving to the left, to the right, up, down, any direction you want, but it's just moving it, it's translating it. Again, this is GCSE knowledge, but just a recap, okay? So here are some notes on the board that we're just gonna have a look at first before we try any questions, although we do have a question up here. So the graph of y equals f of x plus a, where a is just some constant, is a translation of the graph y equals f of x by the vector 0a, okay? Now I know that we haven't done vectors yet, so don't worry too much about it, but the vector 0a basically means up, okay? So if a is positive, you need to move the graph up. If a is negative, you need to move down. That's all it is, okay? And the graph of y equals f of x plus a is a translation of the graph y equals f of x by the vector negative a, 0. What this is it's a translation to the left. Okay, so if a is positive, we go to the left. If a is negative, we go to the right. Okay, and that's all it is. That's literally it. So if the a is inside of the sort of f of x plus a, then we go sideways. And if it's not, if it's outside, we go up. Okay. The actual shape of the graph does not change. So let's just take a look at a question. F of x equals x squared. Sketch y equals f of x plus 2. Okay? That literally just means take f of x, which is x squared, and add 2 to it. Every coordinate adds 2 to its y coordinate. So normally, the normal graph of f of x looks like this, because f of x is x squared. Okay, that's a quadratic, that's a parabola, we've done this. If we want to translate this thing by the vector a0, or 0a rather, like we've got here, that essentially just means we're going to move it up. We're going to move it up by 2, because it's f of x plus 2. So, all we have to do is remove this, replace the lines, and we're just going to do the exact same graph but a bit higher up, just like that. Okay, so the shape looks a little bit different, same shape, just moved up. Okay, so this is the bottom of the parabola, this is the point 2 now instead of 0, so this has got the actual coordinate 0, 2. This is the graph of y equals basically x squared plus 2. Or f of x plus 2, okay? We've just moved it up. That's it. Okay guys, so we're going to do another example here, a bit harder. F of x equals 1 over x, so this ties into our reciprocal graph knowledge. Sketch y equals f of x minus 1, okay? Something really important to notice is that the minus 1 is inside the f of, okay? It's not a translation downwards. You might think, oh, this is f of x minus 1, so it's going to be lower down. No, it's going to be slightly different to that, okay? So let's just have a little look here. The graph of y equals f of x, which is the graph of y equals 1 over x now, what does it typically look like, guys? Oh, normally, it's going to look like this, where we have got asymptotes on the y-axis and on the x-axis, isn't it? Now, of course, we need to actually translate it. So how do we do that? First of all, we need to notice, if we look at our notes here, we've got y equals f of x plus a. Okay? This is in the form y equals f of x plus a, because you can write this as y equals f of x minus or x, I could say x plus minus 1, okay? That's the same thing as f of x minus 1. It's f of x plus minus 1, right? Which means that we can say that a is equal to negative 1, can't we? Because this is f of x plus a, f of x plus minus 1, okay? Now, of course, if we look at this, we have got a translation of the graph by the vector negative a, 0, okay? Now, negative a is equal to negative 1, which is equal to positive 1. So we're actually going to move this thing by the vector 1, well, 1, I should say 1, 0. We're moving it actually this way to the right, okay? And essentially, we're going to get, let's replace our graph. We're going to get a graph that looks very similar, same shape, but it's been shifted to the right. Now, the reason I chose this exact graph is because we've actually done this question before, previously in one of the reciprocal graph videos. If I can actually draw this dotted line here. We've already seen something awfully similar, okay? So, we're going to sketch the exact same graph, but it's been moved this way. Here's our reciprocal. Just like that. Same graph. I know it's a bit rubbish drawing, but same graph. This is the line x equals 1. And there are no intersections except this guy here because it's been translated, okay? And that's it. So we've moved it this way. Now, if you've seen the reciprocal videos, you might recall that we actually did this exact graph. We sketched this exact graph. So you notice essentially we can say if we replace every time we see an f of x, or every time we see an x with an x minus 1, we essentially get y equals f of x minus 1 is the same thing as y equals 1 over x minus 1, like this. This is basically what we just drew, because we're replacing, what does f of x mean? It means if you were to put something that wasn't an x there, maybe f of 0, f of 1, f of 2. If you were to put some value there, you replace every time you see an x with that number. You can do the same thing with like x minus 1. You can replace an x with an x minus 1, which is what we've done here. So f of x minus 1 is the same thing as 1 over x minus 1 for this question, okay? So we have actually drawn this exact graph before, so we know it must be correct. We know it must be because we've done it in a previous video. And again, guys, that is basically it for this topic. So if we want to be looking at translating graphs, this is what we do, okay? Plenty of practice for this one, guys. So if you have sort of this graph, and also, but one more thing, by the way, guys, is that if you're not sure whether you've drawn this right, you can check it, because we know where the asymptote is. It's at x equals 1. What number is x not allowed to be in this graph? 1, because that would make 1 minus 1. So we know the asymptote's right. We know we've gone the right way. If you're worried whether you need to go left or right. The only thing counterintuitive about this is that if you have the a term, like over here, the a term in here, you get like a negative. So you sort of have to go the other way to the way that you might think that you do. But the top one, f of x plus a, very straightforward and intuitive. You just make the graph higher up or lower down. This one, left or right, but it's like the negative of what you might think it is. So whatever a is, you go sort of the other way, okay? But yeah, as I say, lots of practice for this one, guys, lots of questions. That is it. If you want more of this topic, please let me know and I will make more videos. But for now, that is all, guys, and I'll see you in the next one. Cheers.